Prove the vector identity gradient of A dot B that is equal to vector A cross curl B plus vector B cross curl A plus A dot del operator with vector B plus B dot del operator with vector A. So to prove this, the LHS, the left hand side of the identity, that is gradient of A dot B, can be written as grad dot A dot B, because A dot B is a scalar. So when the scalar, you take the dot product of a scalar quantity with the del operator, that is called your gradient. So gradient can be represented as del dot A dot B, but del operator can be written as I cap partial derivative with respect to x plus j cap partial derivative with respect to y plus k cap partial derivative with respect to z dot A dot B. We consider first the x component. If you consider the x component, then gradient of A dot B will be equal to, if you take the dot product of I cap partial derivative with respect to x with A dot B, that will be equal to I cap first function derivative of the partial derivative of the second function plus second function dot partial derivative of the first function, or here I have written partial derivative of the first function dot b. Suppose this is equation number 1, and using vector triple product you may write, suppose you use vector triple product A cross I cap cross partial derivative of b with respect to x, because to find this vector, this identity, that is I cap A dot partial derivative of b with respect to x, you use this vector triple product, that is A cap cross I cap cross partial derivative of b with respect to x. Then you use the BAC minus CAB rule for vector triple product. Using that rule, that will be equal to A dot partial derivative of b with respect to x I cap minus A dot I cap partial derivative of b with respect to x. This we have proved in previous video, that is BAC, commonly known as BAC CAB rule. So using that rule you can find out the vector triple product. So if you take this one, that is I cap A dot partial derivative of b with respect to x to the left hand side, then in the right hand side will be this vector triple product you take to the right hand side. So this will be equal to, or you may do like this, you keep it in the right hand side and write it in the left hand side, and you take these to the left hand side and write it in the right hand side, so that and this side will be equal to A cross b I cap cross partial derivative of b with respect to x plus A dot I cap partial derivative of b with respect to x. And this is nothing but, you can write this as A vector cross curl b plus, this can be written as A dot del operator with b and multiplied with b. Suppose this is equation number 2. So this value we have found out here, this one, and if similarly you can also find the value of I cap partial derivative of A with respect to x dot b vector, and using the same vector triple product method writing in this equation, that means you write b in place of A and A in place of b, then you will get this one, that is I cap partial derivative of A with respect to x dot b, that is equal to b cross curl A plus b dot del operator multiplied by A vector. Suppose this is equation number 3. Now what you do, you substitute the value what you have found out in equation 2 and 3 in this equation 1. So the gradient A dot B that will be equal to A cross call B plus B cross call A plus A dot del operator B plus B dot del operator A. And this we have found out only for the X component, and this will be actually found out by using the Y component and Z component, and if you add the three components you will get this result, that is gradient of A dot B equal to A cross call B plus B cross call A plus A dot del operator B plus B dot del operator A. And this is a very useful identity in vector calculus. So you remember this vector identity, which will be helpful in various applications in physics.